Hello guys, this is Dr. Possibility from Excel Academy. Kindly make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy. In this tutorial, I am focused on how to find the range of radical functions. So please make sure that you watch my previous tutorial where I explained on how to find the domain of a radical functions. So let's quickly get started and look at some few examples. So the example is find the range of each of the following function. So the first one we have been given is f of x is equal to square root x. The second one is f of x is equal to square root 2 minus x. And the third one is f of x is equal to x squared minus 4. So let's quickly look at the first one. So when you look at the first one, it's very simple to find the range. So for you to find the range, you need to have an idea on how to find the domain. So if you look at the domain of this guy, if you look at the domain of this function, we can just simply say domain is equal to x such that x should be greater than or equal to 0, such that x is a member of what? Real numbers. So when you look at the domain of radical functions, you need to understand that the domain of radical function predicts the range of that function. In short, what I'm just trying to say is that the range of a radical function depends on its domain. So if you look at this function, we can easily try to sketch it out, whereby we can have the y-axis and we can also have the x-axis. So you need to understand that whenever we try to come up with a sketch of the graph of this graph, we need to understand that there is something that we can observe, such that let's say we have x here and y here. So when x is 0, you need to understand that y will be what? Square root 0, which is 0. And then when x is 2, let's say the x is 1, you need to understand that it's going to be square root 1, which is 1. When x is 4, we need to have square root 4, which is just 2. When x is 9, we need to have what? Square root 9, which is just 3. So these are the values that we are going to find. So if we were to sketch the graph of this guy, you need to understand that the graph will normally behave in that manner. The graph will normally behave in that manner. So this graph which I have just sketched, its y is equal to square root what? X. So if you look at the range, which is y there and x there, so the range in this case, you need to understand that the range is what? Is greater than 0. So our answer for the range in this case, is simply what? Y is greater than what? 0. Is greater than or equal to 0. So you can write range is simply equal to y such that y is greater than or equal to 0, such that y is a member of real numbers. So this is the solution for this question. So let's quickly move on and look at the next question. So the next question, we have been asked to find the range of this particular question. So we are going to say solution. So like I said, for you to know the range, you need to know the domain. So we first need to look for the what? For the domain. So if you check out the domain of this function, it's simply x such that 2 minus x is greater than or equal to what? 0, such that x is a member of what? Real numbers. So if you work out that, and when you watch our previous tutorial video, I've already explained this expression. So we discover that the domain of this expression is just x is less than or equal to what? 2, such that x is a member of real numbers. So when we check up this question and we try to sketch this question, this is how the graph can look like. This is how the graph can look like. So let's say we have the x-axis here. the y-axis, and then we have the what? The x-axis. So to sketch the graph of this guy, one thing we need to understand is that the values of x are less than what? 2. Meaning if 2 is there, this is where it is starting from, and the values are going this side. And you need to understand that in this case, y cannot be equal to what? Y cannot be less than what? Less than 0. So it's going to start from here going this side. It's going to start from here going this side. And then if you look at this particular point, there is a point there, the value of y. So if you look at the value of x when y is equal to 0, the value of x when y is equal to 0, or the value of x in the y-axis. So you need to understand that when we look for the point here, the point here is just what? Square root what? Square root 2. This is the case where x is what? Is 0, such that when x is 0, then y is equal to square root 2. So y is equal to square root 2 minus x. So when x is equal to 0, you are going to have y 2 minus 0, and this is just the square root what? 2. So this is the graph. So if you look at this graph is just the graph of y is equal to square root 2 minus x. Y is equal to square root 2 minus x. So to look for the range, in this case, to look for the range, you can just simply say y such that y is greater than or equal to what? 0, such that y is a member of real numbers. So this is the range of what? Of this function. Remember, you need to understand that this is the y-axis and this is the x-axis. So in case of this y, the values of y are just going what? In the positive direction. They are all positive. You don't have anything below here. Okay, so let's quickly move on and look at this last question. So like I've been saying, you need to understand that the domain of a radical function will help you to come up with a graph, and that graph will help you to come up with the what? With the range. So let's quickly look at the solution for this question. So the first thing you need to look for is the domain. The first thing we need to look for is the domain. So the domain is equal to x, such that you get what is inside. So you say x squared minus 4, and then is greater than or equal to 0, such that x is a member of real numbers. Then after you do that, you can work out that. So when you work out that, this will be x such that you say x squared is greater than or equal to 4, such that x is a member of what? Real numbers. And then from there, what we can look for is what? We can look for the square root of that. So this can be what? Can be x such that you say square root of x squared, and then is greater than or equal to positive or negative square root what? 4. And then such that x is a member of real numbers. Then when you do that, you can simply finish it up. You say x such that x is what? Is greater than or equal to 2, or x is less than or equal to negative 2. Remember, we have an issue of a negative. So when a negative is being introduced, then you are going to put what? Less than or equal to. The sign will change there. So such that x is a member of what? Real numbers. So after you do that, you have found the domain of this particular function. You can easily come up with the graph. So you can easily come up with the graph. So this is the graph And in this case, you need to understand that it's starting from 2. So there 2 going that way, 2 going that way. So you have a 2 there, and then you have -2. When you plug in -2 there, it will go this other way. Yeah, it's going this other way. Yeah, so in this case, this is how the graph can look like. Remember, when you put anything there which is less than -2, it will surely give you a positive number. So when you look at this, the answer for the range is just simply equal to what? The range is just simply equal to x is greater, y is greater than what? 0. Y is greater than what? 0. So we'll say y such that y is greater than or equal to what? 0, such that y is a member of real numbers. So please make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy. Thank you very much for joining me. This was Dr. Possibility from Excel Academy.